Alright, in this video we're going to try sort of a challenging type problem using dimensional analysis. So we have this problem about dwarfs and mining diamonds, and it's basically asking us how many hours they have to work to get 0.5 kilograms of pure diamonds. So essentially we're converting kilograms into hours. That's our goal. So we want to figure out all the things that we can piece together here. So what do we know about this? We know that in 1 hour, a dwarf can mine 0.08 meters cubed of rock. So I'm going to kind of cheat a little here and say, okay, well, there's 7 of them. So that means in 1 hour, they can mine 7 times that amount. So 0.08 times 7, in 1 hour, they can altogether, they can mine 0.56 meters cubed of rock. So that's one conversion we're going to need. And then we say that the rock is this % diamond by mass. So that means that for every 100 whatever unit we want, let's come back to this actually to see what we're going to use. The rock has a density of 17.1 grams of rock for every 1 milliliter of rock. So that's going to be important. And okay, so let's go back to our thing here. So we're trying to go from kilograms of diamonds to hours. So in this situation, we're going to need to figure out how much rock there is. So we're given the amount of rock in kilograms, so it might make sense to say that for every 100 kilograms of rock, how much diamond there is. And in this case, it'd be 1.3 times 10 to the negative 4 kilograms of diamond. So that's important. So let's see if we got everything we need. We're in kilograms of diamond to start. And from kilograms of diamond, we can get ourselves to kilograms of rock. That's great. And then from kilograms of rock, we can use this to get to milliliters of rock as a volume. We are going to have to do a kilogram to gram conversion, so we should probably write that 1 kilogram of rock is equal to 1,000 grams of rock. And then once we're in grams of rock, we can use the density to get to milliliters of rock. But then, in order to get the time, we're in meters cubed. We're going to have to go from milliliters to meters cubed. So we got to remember that a milliliter is equal to a centimeter cubed. And now we have to get from centimeters cubed to meters cubed. So now we got to remember this, that 1 meter is 100 centimeters using the metric conversions. But a meter cubed, remember we got to cube both sides to get it to that. So if we cube both sides, we learn that a meter cubed is 100 times 100 times 100, which comes out to be 1,000,000 centimeters cubed. So we're going to need to use that. So this is all the process, everything we need to do to kind of start this problem. So now it's just a matter of putting it in place. So we have 0.50 kilograms of rock, diamonds that we want. And then the idea is that, okay, for every 1.3 times 10 to the negative 4 kilograms of diamonds, we are going to need to get 100 kilograms of rock. Okay, that's our starting point. And then the next part is, okay, now we have the kilograms of rock. What we would like to do is figure out how many grams of rock that is. So for every kilogram of rock, we are going to have 1,000 grams of rock. And then we say, okay, the density of rock for every 17.1 grams of rock, there's 1 milliliter of rock. Great. And then for every 1 milliliter, there's 1 centimeter cubed. And then for every 1,000,000 centimeters cubed, there's 1 meter cubed. And then for every 0.56 meters cubed, it's going to require 1 hour of work. And that's the whole process here. Now it's just a matter of multiplying it out. So I get my calculator and I type this out. And when I do this all on my calculator, I get about 40.2 hours. And if we want to play the sig fig rules, it looks like about 2, so probably about 40 hours with the decimal point of work, which, hey, works out perfectly well to be 1 work week. I didn't even plan for that. So anyway, that's how you would approach a problem like this. It certainly takes a lot of time. I kind of rushed through this, but really it's about laying out all these things and trying to make the connections you need to go from one unit to another. So practice with these. They're tough. Like, this is one of the trickier parts of chemistry, is just doing this methodically and showing your work. So until next time, I am Derek Genova. Have a delightful day.